Hello, my name is Matthew Fleming, and today we have a three-part video series for you going over the bubble and the dew pressure and temperature. And so all these are the pressure and temperatures associated with when you have a system of completely liquid that goes and you have your first bubble of vapor, and the pressure and temperature associated with a system that is completely vapor and your first liquid drop condenses. So it all stems from Raoult's law. The mole fraction of the liquid component I times the pressure of the component I is equal to the mole fraction of the vapor and component in the component I times the pressure of the entire system. And so what if you have a system that's made up of two different components, say compound A and compound B? Well, you can actually just write out this equation, but for compound A and compound B separately, and then add both sides together, and that'll look like this. From here, it's important to note that YA plus YB is equal to 1, because that's how the mole fractions are defined, and XA plus XB is also equal to 1. So we can rewrite this right side in the following way. So we can draw out P and just have YA plus YB here. And of course this equals 1, so the right side is actually just equal to P. You can also put it in only terms of your liquid component A instead of having the liquid component B in there as well by simply writing it in the following way. And so say we want to find the pressure that is associated with the moment that we have a completely liquid system and the first drop of, or the first bubble of vapor is found. And so we know that the vapor of our substances will always begin when the pressure of that component is equal to the pressure outside the system. And so say the pressure outside the system is equal to 1 atmosphere. Now we can vary these pressures until we get this entire equation equal to 1 atmosphere. And once that occurs, then these liquid molecules will begin to go into the gaseous phase. And we can vary these pressures by just simply varying the temperature. The number of moles in our system is always going to be the same, and the rate constant, or the gas constant, of course, will be the same. And we aren't changing the volume either. And so the only thing that can change is the temperature, and it's going to change directly with the pressure. So if we increase the temperature, we will increase the pressure, and if we decrease the temperature, we will decrease the pressure. And so say we want to get all of our liquid into the vapor phase. We can lower the temperature or we can lower the pressure, and by lowering that pressure, we will allow some of the liquid molecules to begin to become vapor molecules. And the second that one of these vapor molecules is formed, then we've found our dew pressure. And we've also found the dew temperature associated with that pressure. And if we want to do the same thing, we have a system full of just gas and we want to condense it to make it liquid. What we can do is we can increase the pressure until the temperature, or until the pressure is just at the right moment where our first drop of liquid occurs. And once that happens, we'll have the dew point. So it's important to mention that, say we have the temperature is constant, the volume is constant, the amount of moles in the system is constant, then if we have a mole fraction and we have and we vary temperature with it, this is what that might look like on a graph. And so say we have a system and we want to increase the pressure so that we can reach only liquid, and say we have only vapor. So we're starting somewhere down here, depending on whatever mole fraction you have, and say we want to reach the liquid, so we're going to increase the pressure here, and as soon as it hits this dotted line right here, you're going to form your first drop of liquid, and that is, of course, your dew point. And then you're going to keep increasing, and whenever you're in between these two lines, you have a mixture of some of the two. And then once you hit this point right here, it's going to be all liquid from here on out. And that's when you've made your entire system liquid.